everyone. In this video, let us solve two problems on bivariate random variables. Let us try to solve the first problem. The joint PDF fxy x comma y is defined as equal to 3, a constant, for the range x value varying between 0 to 3, y value varying between 0 to 3, and it is 0 otherwise. And the first part of the problem, what is the value of the constant 3? What are the PGs for x and y? What is fxy x comma y for the range x value varying from 0 to 3, y value varying from 0 to 3? What are fxy x comma infinity and fxy infinity comma y? Are the x and y random variables independent? We obtain the PDF by integrating the PDF. Since x and y are bivariate random variables, and we can obtain the PDF integrating the PDF twice, once with respect to x and second time with respect to y, and that should be equated to 1. Fxy of 3 comma 3 is equal to 1. Now fxy x comma y is defined as 2. Let us make this substitution and try to integrate. So let us integrate this. Here 0 to 3 3x, 0 to 3 is 3y. So this is 0 to 3 c3 3y. So this is c3y 0 to 3, that is equal to c9 equal to 1. So c equal to 1 by 9. Let us try to obtain the marginal PDF value fy of y, fx of x. PDF fy of y is given by integral 0 to 3 1 by 9 dx. So when you integrate this, you get this as 1 by 9 x value varying from 0 to 3. So you get this as 3 by 9, that is equal to 1 by 3. Similarly, we can obtain fx of x, that is integral of 0 to 3 1 by 9 dy, that is equal to 1 by 2. Third part, we need to find out the PDF fxy of x comma y. It is given by integral of PDF. We have to integrate the PDF twice, once with respect to x, second time with respect to y. So when we integrate first time, we get this as 1 over 9y. Second time when we integrate, we get the answer as 1 by 9 xy, and it is valid for the range 0 to x value between 0 to 3, y between 0 to 3. Fourth one, we need to find out fxy x comma infinity. Here x value can take anywhere between 0 to 3. So therefore integral of 0 to x, and y value varies up to infinity. So therefore 0 to infinity fxy of xy dx dy. So I can, here the maximum value of y that can take place, the range itself is defined as 3. So I can write this as y value varies from 0 to 3, x value varies from 0 to x, 1 by 9 dx dy. So when I integrate it, I get this as 1 by 3x. Similarly, I can obtain fxy of infinity comma y, that we get it as 1 by 3y. Lastly, we have to specify whether they are independent or not. We have to make use of the formula whether fxy of xy is equal to the product of marginal PDF of x and y. So when I multiply fy of y into fx of x, I get this as 1 by 9, that is equal to fxy of x comma y. Therefore, we can say that x and y are independent. We take the second problem. A bivariate PDF for the discrete random variable x and y is defined as 0.2 delta x delta y plus 0.3 delta x minus 1 delta y plus 0.3 delta x delta y minus 1 plus 3 delta x minus 1 delta y minus 1. We need to find out the constant p. What are the PDF for x and y? And what is the PDF fxy x comma y for the range of x between 0 to 1, y between 0 to 1? What are fxy x comma infinity, fxy infinity comma y? Are these x and y are independent? So let us try to find out the PDF value. The PDF, always get it by integrating the PDF twice, once with respect to x, second time with respect to y. And we know that fxy of 1 comma 1 is always equal to 1. Now let us substitute the value of fxy given in this equation. So I have substituted the given previous value here, yes, and then try to integrate this with respect to x and y. So when I do this, I can get the answer equated to 1. I can get the value of 2. So when I integrate this, I get this as 0.2, this 0.3, and this is 0.3, then 2. When I add them up and equate it to 1, I get the value of p is equal to 1 minus 0.8, that is equal to 0.2. We try to obtain the marginal PDF fx of x and f by fy. This can be obtained by integrating the PDF fxy with respect to y. So fx of x is the integral of PDF fxy with respect to y. So when we integrate this, we make use of the formula integral of minus infinity to infinity delta of x dx is always equal to 1. So therefore, when we integrate delta y with respect to y, we get that as 1. So we are left with the constant term 0.2 delta x. Similarly, we obtain 0.2 delta x minus 1 plus 0.2 delta x plus 0.2 delta x minus 1. We can obtain fy of y by integrating the PDF fxy with respect to x. So when we do it, we get this as 0.2 delta y plus 0.3 delta y plus 0.3 delta y minus 1 plus 0.2 delta y minus 1. This can be further simplified as this is equal to 0.5 delta x plus 0.5 delta x minus 1, and this is equal to 0.5 delta y plus 0.5 delta y minus 1. We can obtain the PDF by doubly integrating fxy, that is PDF, once with respect to x, second time with respect to y. Let us substitute fxy in this formula. We get the formula as double integration of fxy x1, right? We use pv. First, when we integrate with respect to v, we get this as integration of 0 to y 0.2 delta u plus 0.3 delta u minus 1. And here, because for all values of x varying between 0 to 1 and 0 to y, integral of delta v with respect to pv equal to 0. So therefore, we get the answer as 0.2 for x value varying between 0 to 1 and y value varying between 0 to 1. Let us try to obtain fxy x comma infinity by integrating twice with respect to x and y the previous value fxy. The x value varies between 0 to x, y value varies between 0 to 1. So let me substitute fxy in this equation. So the resultant equation will be like this. And when we integrate with respect to x, we get this as 0 integral 0 to 1, and the integration of this will give us 0.2 delta x that I have integrated with respect to y, 0.3 delta x minus 1 plus 0.2 delta x plus 0.2 delta x minus 1. So when I integrate this with respect to x, I get this as the integration of delta function will give us step function. So we have 0.2 ex plus 0.2 ex minus 1 plus 0.2 ex plus 0.2 ex minus 1. The resultant will look to be 0.5 ex plus 0.5 ex minus 1. Let us try to find out fxy of infinity comma y, that is equal to integral of 0 to y 0 to 1 the pdf dx dy. In the same way, we obtain the answer as 0.5 unit function, step function u of y plus 0.5 u of y minus 1. Finally, we need to say whether x and y are independent. That can be checked by equating the fxy, the bilateral PDF, which is the product of the marginal PDF. In this case, the bilateral PDF is equal to the product of marginal PDF, fy of y and fx of x. So we can say that x and y are independent. Thank you. In the next video, let us study something about transformation.